In this video, we will discuss the problem minimum cost to cut a board into squares. So the problem says that we'll be given a length m and we'll be given the width n of a particular board, and our task is to break this board into m cross n squares such that the cost of breaking is minimum possible. So the cost of cutting each edge will be given in the x array and the y array for the x and the y axis respectively, and you need to choose the sequence of cutting in such a way that your cost is minimized, and whatever cost minimized you calculate, you have to return it in the end. Now let us understand this, what the problem is exactly saying. So suppose we had a particular board, suppose we had a board of this kind in which we had this scenario. Okay, suppose we had this board. So in this case, if this is marked as 5 and suppose this is marked as 6, suppose this is marked as 3 and suppose this is marked as 7, then the problem says that for making this edge, right, for making this particular cut on the board, like suppose this cut was not there, right, so for making this particular cut on the board, you will have to pay a cost of 3 into something more. Okay, so basically for making this cut, you will have to pay a cost of 3 into something more. I'll come to this. And for making this particular cut, you have to pay a cost of something like 7 into something pieces, into some pieces. Now what are those pieces? So let's quickly have a look at that as well. So suppose if this is the current board, okay, and in this case, suppose if I make a cut of this 5, suppose if I make a cut of 5, okay, or suppose if I make a cut of 6. So if I make a cut of 6 here, so I am making a cut of 6 into how many pieces, like how many pieces were there initially. So initially I see there is only one piece, okay, so there is only one piece, so I'm making a cut into one piece only, right? So in that case, I'll take a cost of like the cost will be nothing but 6 into the number of pieces. So the number of pieces was 1 only initially before making this cut, so I'll say that okay, 6 into 1 is the cost. Suppose if I make this particular cut, so in that case, if I make this cut, so how many pieces this cut is passing through? Like this cut is passing through how many pieces? It is passing through 2 pieces, right? Because you can see there are 2 pieces. One piece is this piece, second piece is this piece. So when I make this 7 cut, the cut with 7, right? So it is passing through 2 different pieces. So I'll say that okay, the extra cost that will be added here is 7 into 2 because it is passing through 2 pieces, right? So that is how the cost is calculated. For better understanding, let's say that we have, suppose we have 3 pieces here, right? Suppose we have 3 pieces here, okay, and we make a cut, like suppose we make a cut which has a individual cost of 5, okay. So if we are making this horizontal, like this vertical cut, then how many horizontal pieces we have? We have one horizontal piece, second horizontal piece, and we have third horizontal piece. So basically we have 3 pieces. So what is the overall cost? The overall cost will be nothing but 5. That is the cost for making this vertical cut into the number of pieces. So the number of pieces is 1, 2, 3, that is through which I am passing. So that will be nothing but 5 into 3, correct? Now same thing can apply for the horizontal cuts as well. Suppose if I had something like this, if I had 2 pieces here, okay, and I was making a cut like this. If I was making a cut like this, then how many pieces I have before it? So if I see, this is first piece and this is the second piece, right? And I'm making a cut like this. Suppose this takes a cost of 7. So I'll say 7 into 2 is the cost because I'm passing through 2 pieces. Like this was the first piece, this was the second piece, and basically I'm making a cut of 7 through this, right? So that's how I'm calculating the cost. So basically the problem says that you have to cut the given board into m cross n pieces, right? M cross n, like you have to cut everything, like you have to make all the cuts, but you have to make the cuts in such a sequential manner such that the cost is minimum possible. Now when they say that the cost should be minimum possible, so in that case, what is your cost depending on? So every time you are doing what? You are saying that cost plus is equal to nothing but the cost for making either this cost, like you will be given in terms of x-axis, you will be given these values, and in terms of y, you will be given these values, right? So you have to make the cost in such a way that your overall cost, the total cost, is minimum possible. So you have to choose such a sequence. Now how can you do that? So if you will see, so what is the cost depending on? the cost is either depending on xi into, like basically you will be given the x and the y, right? X, like these coordinates and these coordinates will be given to you, right? Basically these costs and these costs will be given as x, and all these costs will be given as y. Okay, now what your task is that you have to minimize the cost. Like how will you do that? So if you will observe, every time what you are doing is you are checking that, okay, what is the cost of making the cut, right, into the cost for a particular making a cut is nothing but the cost for making a cut. That can be either x or y, that will depend on the x array or the y array, whichever I am choosing, into the number of pieces, correct? And if we'll observe one thing, so if we'll observe the number of pieces, so the number of pieces will keep on increasing as we keep on making the cuts. Suppose initially the board is just single, right? If it looks like this, okay, then I make one cut, then I make second cut, then I make third cut. So one by one, if I keep on making the cuts, then the number of pieces will keep on increasing. So if the number of pieces keep on increasing, and if I multiply it with a particular higher cost of cutting, right? If I multiply it with a higher cost of cutting, then my overall cost will also increase. So I should try to do what? I should be a little bit greedy here, and I know that the number of pieces will increase as I keep on making the cuts. Okay, so in that case, what I will say is I'll try to multiply it with the minimum cuts, right? So basically what I will try to do is, like if I see here initially, so what I will try to do here is, if I see that, okay, there is a 7 here, right? Like if I try to see, so what are the possible cuts that I can make? Either I can make a cut of like 5 or 6, or I can make a cut of 3 or 4. So which should be my first priority? Like, should I make a cut of 6? If I make a cut of 6, okay, like if I make a cut like this, then it will be 6 into 1. Okay, that will be the case. But suppose if I go on and make the cut of 7, right? So in that case, what will the cost? That will be nothing but 7 into 2, correct? Like if I have to simplify this, so let's say if you had to make only 2 types of cuts, right? So which cost will be optimal? If you see, if I make a cut of 6 here, then what happens? If I make a cut of 6, then that initially there is only one piece, then I make a cut. So that will be nothing but 6 into 1. Okay. Then after that, if I want to make the cut of 7, right? If I want to make this particular cut, then how many pieces are there? There are exactly 2 pieces. So that will mean that plus 7 into 2. Now what is this cost? This comes out to be 6 plus 14, that is nothing but 20. But can I get a lesser cost than this? Yes. Because if as I said, as you keep on cutting, so the number of pieces increase. So you should multiply, like you should keep the lower cost in the end, so that the cost of cutting is lesser, and then you multiply it with the number of pieces, because the number of pieces will be increasing. So if you multiply it with a lower cost, then the overall cost will be less, or it will be minimal. Now let us say that if you make a cut of 7, so if you make a cut of 7 like this, okay, then what happens? There is only one piece, so you do 7 into 1, right? After that, when you go to make a cut of 6, then there are 2 pieces, first piece and the second piece. So now if you try and make a cut, so you'll make a cut like this, okay, then what happens? So this will be added with 6 into 2. Now what is this cost? This is nothing but 7 plus 6 into 2, that is 12. So that will come out to be 19, which is lesser cost compared to 20. Why this happens? Because you can see that if I first of all take the higher cost cut, like if I first of all give priority to the cuts that are taking higher cost, if I take them first, in that case the number of pieces will be lesser initially. So that is why the overall cost will also be minimal, because if I take the higher cost later on, in that case the number of pieces will be high, which will increase the overall cost. But if I take the higher cost cuts earlier, in that case what will happen? My cost will be minimal. Okay, so basically what I'll be doing here is, if let's say that I have been given, let's quickly check the sample example now and see what we can do here. So suppose if this particular board has been given to us, so let's quickly copy it and see what we can do here. So suppose we have been given x is equal to 2, 1, okay, then 3, then 1, and then 4, okay, and suppose y has been given to us as 4, then 1, and then 2, okay. So basically you have to cut it into a board of this type. Like basically you have to cut it into pieces of 6 cross 4, okay. So now if you will see here, so one cut you will be making like this, a cut of 2, then a cut of 1, then a cut of 3, okay, then a cut of 1, and then another cut of 4. So let me increase the size. 1 second. Let's increase the size. Okay. So now you will make a cut of 4 here. Okay, so that is what you are doing here, and here you are making the cuts like this: 4, then 1, and then 2. You have to choose the sequence in which you will be cutting. So basically, if you will see, so in which sequence will you cut? You will try to make the higher cost cuts, like you will try to make this cut first, then this cut. You will try to make the higher cost first, higher cuts first, because in that case the number of pieces will be lesser. Okay, and here two types of pieces are there. Suppose if I make a cut of this kind, then what happens? If I make a horizontal, like if I make a horizontal, like vertical cut, in that case there is this piece and there is this piece, right? So in that case what happens? The number of pieces increase in this fashion. Suppose like in this case, if you see, if I make a vertical cut, then there is this is one piece and this is another piece. Now these are horizontal pieces, right? And similarly, if you will see, if I make a horizontal cut, then this is one vertical piece and this is another vertical piece, right? So there is this thing also that you have to keep a check, that there are two types of pieces. Because if you make a cut like this, right, suppose this cut was there, now you make another cut of this kind, so this is one piece, second piece, and third piece. So there will be two types of pieces, the horizontal pieces and the vertical pieces. So that is another thing that we need to keep a track of. So first of all, what we'll be doing is we'll be sorting our array according to the decreasing order, because we'll be first of all taking the higher cuts. So we'll first of all sort in decreasing order. So these cuts would look like this. The cuts will be made here only. The 4 cut will be made here only. If you will see, so in this case, they are making this 4 cut in the last only. Okay, so we'll make this 4 cut here only, but we will decide the sequence in which we want to cut. Okay, so 4 is there, then 3 is there, then 2 is there. Okay, then 1 comma 1. Okay, suppose this is there, and in the second case, if I try to sort it, so it will look like 4, then 2, and then 1. Okay, now what happens here? If you will see, so initially I can say that the number of horizontal pieces is 1 only, and the number of vertical pieces is also 1. Okay, and my I will start from here. Okay, now I will start from here. Now if you see M is the size of this array. So M is given as 6. How many indexes do I have? I have 0, I have 1, I have 2, I have 3, I have 4 index, right? But M is given as 6. Why M is given as 6? So if you will look at the diagram, so 1, 2, 3, 4, 5, 6, right? So basically 1, 2, 3, you can see basically 6 pieces are there now. If you will see here, like for this case, if you will see, so N is given, right? N is given as what? 4. Now if you will see, you will make 3 cuts, right? When you make 3 cuts here, then how many pieces are there? Basically 4 pieces are there, right? But if you will see here, so N is equal to 4, but what are the indexes? The index is 0, 1 and 2. So basically you will say that you will have to do a N minus minus, you will iterate until you have to iterate till 4 only in here, that is M minus 2, you can say, or you can say like less than M. Like if you would, if you see here M is equal to 6, you will iterate till 4 only. That is one thing. Another thing that you need to notice here. Okay, after this part is done, so what we need to understand is how will we make the cuts. So I will mark one I here and another J here. Okay, suppose this is like, suppose I check. So now if I check I and J are the same, so let's say I make a cut on this I. Okay, so if I'm making this cut, so initially what is the number of pieces that I'm having? So initially the number of pieces that I can see, the number of pieces that I'm having is nothing but 1. Okay, and what is that piece? So let's say if I'm going to make a vertical cut, right? If I'm going to make a vertical cut, that is if I'm going to make a cut with this X right here, so that will be a vertical cut. So if I'm going to make a vertical cut, then what are the horizontal pieces that I'm having? I'm having no horizontal piece. Like basically I'm having just one horizontal piece and one vertical piece. So if I'm making a vertical cut, then horizontal, like if I'm making a vertical cut, so I'm making a cut of 4. Okay, so I will multiply it with H, that is H value here is 1 only. Okay, like basically if I make, like I'll multiply it with 1 because I'm making one cut only. Like basically the number of pieces is 1 only, right? But when I do this thing, then there's another thing that happens. Now if I see what is the total number of vertical pieces here, so if I see after making this cut, the number of pieces increases. And by how much does it increase? So if you will see here, it increases by a lot. Like if you see here, so it will change to now 2. Why does it change to 2? Because since you have made a cut here, so you can observe that simply, let's say what you have done here is, you can observe that this is one piece and this is another piece, right? So you can observe here that initially I had just one horizontal piece, but now what I have done is like here if you will see, if I made this cut 4, okay, so what happens, this becomes one piece and this becomes the second piece. So I can say that the number of vertical pieces increases, okay, that is, this is one vertical piece and this is another vertical piece. So I'll say that the number of vertical pieces will increase. So I'll increase its count by 1, okay, and I'll move my I to this index. Now if I check, so I is standing at 3 and J is standing at 4. So which cut will I like to make? I'll like to make the cut which is having higher cost, so that because initially the number of pieces will be lesser, so I'll try to make the cuts with the higher cost, okay. So now I'll try to make this cut with 4. So where will I make this cut with 4? So I'll make this cut with 4 here, like horizontally. So if I want to make this particular cut, so how many pieces I am passing through, like how many pieces are there? So one piece and the second piece, that is denoted by V, okay. So what I will do is I'll multiply xi into the h, okay, and I'll do v plus plus a, okay. And what I will do, like when I'm using y, so in that case when I'm using this 4, when I'm using y, so in that case what I will do is I'll say that, okay, yi, which is yj, which is nothing but 4, okay, which is nothing but 4 into the number of vertical pieces, right, into the number of vertical pieces that I had, okay, that is what I will do, into nothing but 2. And in that case, now when I make this particular cut, in that case, when I've made this cut, in that case you can see that the number of horizontal pieces, like this is one horizontal piece, this is the second horizontal piece. So now in this case the horizontal pieces increases. So in that case what I will do is I'll do a horizontal plus plus, okay. So the horizontal piece will increase to 2. That is what I'll be doing, and I'll keep on doing this repetitively with the help of this 2-pointer approach. So basically what I'm doing is I'm sorting these arrays in descending order, and then I'm applying the 2-pointer approach smartly to make the cuts in such a way that the cost is minimum, because first of all I'm taking the higher cuts, like the cuts which are having the higher cost, because initially the number of pieces will be lesser. So if I'll multiply the higher cost with lesser pieces, in that case the cost will be minimum, and then when my pieces will increase, then I'll be multiplying them with the lesser cost of cutting values, so that will reduce my overall cost, okay. So let's try and write the code for this approach and see what I'll be doing here. So what I'll be basically doing here is, first of all I'll sort the given array, like I'll sort the x array and the y array. So I'll say that, okay, sort x dot begin, okay, comma x dot end. So I'll first of all sort the x array, okay, and I'll sort it in decreasing order. So I'll write greater int here because I want to sort it in decreasing order. So I'll sort it in decreasing order, that is higher values will come before, okay. Then what I'll do is I'll sort y dot begin, comma y dot end. So I'll sort the y array as well, and I'll sort it as well in decreasing order, okay. That is what I'll be doing here. Now once I've done this, so I will say what? I'll say that, okay, the horizontal number of pieces is 1 and the vertical pieces is also 1, okay, because initially there is only one piece, okay. After this I'll mark my I as 0 and I'll mark my j as 0. This is I will be pointing to the x array, and j will be pointing to the y array. Now another thing that I need to do here is I need to have the cost. So I'll mark the total cost as nothing but 0 here, okay. Now there's one more thing that we need to do. Now till where will my I go, right? So I will go till where? I will go till maximum this value. Now what is this? If I see, so this, like suppose I goes till here, right? Suppose I goes till here. So this is nothing but 5, but m value is 6. So that is why what I will do is I'll do a m minus minus, because m is 6. M is equal to 6 denotes the number of overall segments, but basically the number of elements in the array is 5. So I'll do a m minus minus. Similarly, if I see n, so n is equal to 4. Now suppose if my j moves one by one and my j moves to this index, so this is nothing but 3 index, right? So j should be moving lesser than 3, but basically n is equal to 4. So I'll do a n minus minus as well. So that is what I'll be doing here. So I'll do a m minus minus, and I'll also do a n minus minus here, okay. These are the things that I'll be doing basically. After this part is done, so what I'll be doing here is I'll say that, okay, now I need to start my iteration while I is lesser than the m value and the j is lesser than the n value, okay. While they do not, like, if any one of them gets exhausted, right? Suppose what happens is, like, you must have seen this thing while merging two arrays. So suppose this is the x array, okay. Suppose this is the x array in descending order, and suppose this is the y array, okay. Suppose what happens, one by one I keeps on iterating and I reaches the end, and still j is standing somewhere here, then after that what will happen, I'll keep on iterating and I'll keep on cutting until I exhaust the j array, right? This is one thing. So basically when one of the array gets exhausted, then whichever array is left, I will be iterating through it to calculate the overall cost. Another thing that could have happened is, suppose I is still standing here and I exhaust the j array, right? I exhaust the second array. So in that case, if j comes to the end, in that case what I'll do is I'll terminate and then I'll complete the ith, I'll complete the x array, I'll complete all these cuts, right? So I'll add their cost. Okay, so I'll be iterating until if any one of them becomes, if any one of them exceeds, if any one of the array gets exhausted, in that case I'll simply terminate and whichever array is left, that I'll complete. Okay, so what I'll do is, if suppose that the xi, if it is greater than the yi, okay, if it is greater than the yj, in that case what I will be doing here is, I'll say that okay, I'll say that okay, the cost will get added with the value as nothing but xi into, the cost will get added by xi into the horizontal, as I had already discussed. Like if I am making a cut like this, like suppose if I am making a cut like this, okay, so the horizontal number of pieces initially were 1, so it will be multiplied with horizontal. You can see here xi will be multiplied with horizontal, and in that case the number of vertical pieces, you can see, will increase by 1. So what vertical piece initially was 1, now it will get incremented to 2, so it will get incremented by 1. So xi will get multiplied with h, okay, and then what I will do is I'll increase the number of vertical pieces and I'll also move my I pointer by 1. Okay, that is what I'll be doing. Else if it happens that yj is greater or equal to xi, in that case what I'll do is I'll say that okay, the cost plus is equal to nothing but yj into the vertical, right? Because if suppose that I am making a y cut, if suppose that I am making a y, like if suppose that I have already made the x cut here, now if I'm making the y cut, if I'm making the y cut, so like if I'm making this particular cut here, if I'm making this particular cut here, so what will I multiply it into? So yj, that will be nothing, the cost will be nothing but, it will be nothing but yj into this thing, into what? Into the number of vertical pieces that are there. And what are the vertical pieces that I have? That is nothing but 4 into 2, because 2 vertical pieces is what I have. And then what happens? After this, you can see that the number of horizontal pieces will increase, because this is one horizontal piece and this will be the second horizontal piece. So in that case, the horizontal piece will get incremented by 1 and it will get incremented to 2. So in that case, I'll say that horizontal plus plus. Okay, so that is what I'll be doing. So I'll say okay, j plus plus, and I'll say that okay, horizontal plus plus will also be done here, right? So that is what I'll be doing here. And after I exhaust one of the arrays, so you must have seen while merging two sorted arrays, if one of the array gets exhausted, then what I will do is I'll use the left, like whichever array is left, whichever array is not exhausted. So I'll iterate through it and I'll calculate the cost. So if suppose that the first array is not exhausted, in that case what I'll do is I'll say that okay, cost plus is equal to nothing but the xi, okay, the xi into the height, into the horizontal pieces, that is what I'll be doing. And I'll be doing I plus plus, and I can also say that I'll be increasing the vertical pieces, although that is not required. Otherwise, if suppose that if the y array is not exhausted, in that case what I'll be doing here is I'll say that okay, in that case we will simply do what? We will simply say that okay, the cost plus is equal to nothing but the yj into the vertical pieces, as I have already discussed in the upper part. Okay, and then once this cost is added, then I'll do a j plus plus here, and I'll also increase the horizontal, so I'll do a h plus plus here. And in the end, once I've calculated the overall cost, so what I'll do is I just need to return the cost. Okay, that is what we'll be doing here. Let's try and compile this code to see if it works or not. Okay, it works on the samples. It gives us the output as 42. Let us try and submit this code as well. So you can see that our solution is working for all the test cases that are there in this problem. Now talking about the time complexity of this code. So the time complexity for this code will be nothing but, first of all, we are sorting the first array in the decreasing order. So that will take m log m time. Okay. Then we are sorting the second array that is given in the decreasing order. So that will take another order of n log n time. Then we are iterating through the first array. So that will take order of m time. And then we are also iterating to the second array in the worst case n pieces, so order of n and m, right? So the overall complexity of the code will be nothing but m log n plus n log n, because these factors will be contributing to the time complexity, because this is linear and these are having logarithmic expressions. So the overall complexity will be nothing but m log m plus n log n. Okay. And talking about the space complexity for this code, so since we are not using any external space, any extra space, so the space complexity will be order of 1. If you understood this explanation, make sure to hit the like button and comment down understood as well. Thank you.